Hello everyone, welcome to Brain Blitz Audios. Today, in this episode of Cbse board exam, we'll be continuing our discussion of the sample paper published by Cbse for the year 2021. This is the second video in that series, and in order to get that first video, then you can always go back to our playlist and then search it out. Now, in this episode, we're going to be discussing a very special question. So in this year's sample paper, they've introduced a question called case study based questions. So in section 2, both the case study based questions are to be compulsorily attended, and you have to attempt any of the 4 subparts, and each of these questions carries 1 mark. So we will have 5 questions in each of the case studies, and you need to attend 4 of them. And if you attend 4 of them, you'll get 4 marks from that case study, and from the other case study you get 4 marks, so you have a total of 8 marks in section 2. So we'll be looking at the first case study today in the sample paper, and this is question number 17. An architect designs a building for a multinational company. The floor consists of a rectangular region with semicircular ends having a perimeter of 200 meters as shown below. The length is given as x, and the breadth is given as y, and the radius of the semicircular end is y by 2. Now, based on the above information that you get, we have to answer the following. This is sub-question number 1. If x and y represent the length and breadth of the rectangular region, then the relation between the variables is. So, in this question, the perimeter is given to us as 200 meters. So the perimeter of the whole building of the whole floor is 200 meters, and the floor consists of a rectangle of length x, breadth y, with semicircular ends of radius y by 2. So in order to find the perimeter of the equation for the perimeter of the rectangular region, we need to consider the length of the rectangle and the semicircular arcs. So the 2 sides of the rectangle, which we are considering, that is this part and this part, both are of length x. So x meters each. So we will be having a total of 2x contributed by the rectangle. The circumference, that is the total circumference from both arcs, is 2 pi r divided by 2 into 2. So you have 2 pi, and then the radius here is given as y by 2. So we have 2 pi y by 2 as the total circumference from both the arcs. And the length, which is contributed by the sides, is 2x. So total perimeter is given to us as 200, and therefore you can write 2x plus 2 pi y by 2 is equal to 200. The 2 and 2 gets cancelled, so you have 2x plus pi y is equal to 200. This is the equation for the perimeter of the office building. And if you look at our options, you see that option 2 is the right answer. The trick here is to identify which component of the semicircle and the rectangle are part of the perimeter, and then calculate accordingly. In the second part of the question, the area of the rectangular region A expressed as a function of x is. So earlier notice that we have 2x plus pi y equals 200 as our equation. So now we need to convert this with y on one side and an equation with terms of x on the other side. So pi y now becomes 200 minus 2x, and y equals 1 by pi times 200 minus 2x. So this is the value of y in terms of x. Now, we need to find the area of a rectangular region. Area of a rectangle is always the length times the breadth. So, the area of rectangular region A can be calculated as x times 1 by pi into 200 minus 2x. And once you've done that, then you can multiply x to the bracket inside, and so what you'll get is 1 by pi into, in the bracket it's 200x minus 2x squared. So that we can now write it as 2 by pi into 100x minus x squared. Basically, we're taking 2 out of the bracket. So 2 times 100 is 200, 2 times 1 is 2. So the final answer is option A, 2 by pi into 100x minus x squared. This is the equation representing the area of the rectangular region A. Now, the third question is asking us to find out the maximum value of the area A. So in order to find the maximum value for the equation, that is 2 by pi into 100x minus x squared, what we're going to do is we're going to differentiate the equation with respect to x. So the left-hand side is dA by dx, and the right-hand side is d by dx of 2 by pi into 100x minus x squared. So 2 by pi is constant, so it's taken out. And then 100 times d by dx of x, that will be just 100, minus d by dx of x squared will be 2x. So you have 2 by pi into 100 minus 2x as dA by dx. So next, what we do is we put the value of dA by dx is as equal to 0. So the step is for maxima and minima, dA by dx is equal to 0. So this is a statement that you have to write when you're solving this question. So now we know that dA by dx is equal to 0. So that means 2 by pi into 100 minus 2x is equal to 0. And 2 by pi can be taken to the right-hand side as pi by 2. So 100 minus 2x is pi by 2 times 0. 100 equals 2x. And x is 100 by 2, which is 50. So the value of x is 50. So now you got the value of x. Let's put the value of x in the equation for area. So A is equal to 2 by pi into 100 times x is 50 minus x squared is just 50 squared. So 2 by pi into 100 times 50 is 5,000 minus 50 squared is 2,500. So that is 2 times 2,500 divided by pi. So that means the maximum area that you get is 5,000 divided by pi meters squared. And that is option C. So by deriving the equation for area, you get the value for x in the case for maxima and minima, and you need to find maximum value, so just put the value of x in the equation A and you get the maximum value as 5,000 by pi meters squared. Now, the fourth question. The CEO of the company is interested in maximizing the area of the whole floor, which means they're including the semicircular ends in the area. So for this to happen, the value of x should be, in order to include the semicircular ends, the value of x should be. So the total area that is present inside the perimeter is the area A plus 2 times the area of the semicircle. So that means it will be 2 by pi into 100x minus x squared plus 2 times of 2 times of half into pi into y by 2 the whole square. So it'll be 2 by pi into 100x minus x squared plus 2 times half is just 1. So you have pi y squared divided by 4. Now, what we're going to do is we will put y is equal to, 1 by pi into 200 minus 2x on the right hand side. So now what we get is total area is equal to 2 by pi into 100x minus x squared plus pi by 4 into 1 by pi into 200x 200 minus 2x the whole squared. So now what we get is 2 by pi into 100x minus x squared plus pi by 4 into 1 by pi squared into, now what we're doing is we're taking 2 squared outside from both the terms. So we'll get 4, that is 2 squared, into 100 minus x squared. 100 minus x, the whole square. So now what we get is 2 by pi into 100x minus x squared plus pi and pi, one of the pi's in the denominator gets cancelled with the numerator, and both 4's get cancelled. So now we have 1 by pi into 100 minus x the whole squared. So let's multiply all the terms. So 2 by pi times 100x is 200x by pi, and then minus 2 times x squared is 2x squared divided by pi, plus 100 minus x the whole square will be 100 squared plus x squared plus minus 2 into 100 into x, that is 200x, and you multiply 1 by pi to all of these terms and you get this equation. So over here 200x by pi, 200x by pi gets cancelled, minus 2 plus 1 becomes minus x squared by pi plus 100 the whole square divided by pi. So this is the total area, and we can represent this equation as z. So that means the derivative of z with respect to x will be minus 2x by pi plus 0. So minus 2x by pi will be the answer. So now we have to get the maximum value. So for maxima and minima, dz by dx is equal to 0. That means minus 2x by pi is equal to 0. X is equal to minus pi by 2 times 0. So the value of x is equal to 0. So for the maximization to happen, the value of x has to be equal to 0 meters. So there should be no rectangle, only a circle. Circular building is what the CEO needs. So in order to maximize that area, the value of x should be equal to 0. Now, the extra area generated if the area of the whole floor is maximized is, so the answer here is no change. Both areas are equal. So x goes to 0, and then you only have the semicircular area, and that semicircular area is equal to the area of the floor before. So therefore, there is no change. Both areas are equal. Option D is the right option. Now, this was the first question out of the case study questions. We hope you found this video interesting. We'll be back with the second case study question as well. So don't forget to refer to our Section A video by clicking on the playlist in the description down below. And if you want to support us and watch more of our useful and interesting content, then you can subscribe to our channel, which is Brain Blitz Audios. So until the next webisode, take care, stay safe, bye-bye for now.